According to the United Nations Human Settlements Program, more than 1.6 billion people in developing countries around the world live in unsafe and overcrowded housing. Over the years, people living in these conditions are the ones who have been the most vulnerable to the devastation caused by earthquakes, hurricanes, tsunamis, floods, and other natural disasters. The high cost of construction materials and shortage of skilled labor have impeded progress towards addressing what has become a global housing crisis. Based in the United States, Waffle-Crete International offers a solution with the potential to reverse this trend. For 35 years and in more than 30 countries around the world, the Waffle-Crete building system has provided safer, faster, and a more affordable alternative to the conventional brick and block construction. Waffle-Crete buildings are made from durable and long-lasting reinforced concrete, using up to 60% less raw materials without sacrificing strength or safety. The Indonesian government selected the Waffle-Crete system to construct this 5-building, 5-story, low-income housing project in its capital city of Jakarta. Not only did Waffle-Crete construction provide the fastest and lowest cost option, it did so while also exceeding rigorous test standards in the Indonesian seismic testing laboratory shown here. To illustrate how the Waffle-Crete system works and just how effectively it saves time and money, we captured the construction process by building the small, low-cost house that you see depicted in these drawings. In the next few minutes, you'll see the house come to life. It will require us to cast and erect 4 Waffle-Crete grade beams, 3 Waffle-Crete floor panels, 4 exterior Waffle-Crete panels, 1 interior Waffle-Crete panel, 3 Waffle-Crete roof panels, 2 columns to support the cantilevered roof panel, and finally, 24 eave trim panels. At the heart of the Waffle-Crete system is a rugged plastic and aluminum mold that is both lightweight and portable. Waffle-Crete molds can be made in almost any size or shape needed for a particular building design. The first step is to coat it with form oil. This will make it easier to remove the hardened concrete panel from the mold. Prior to filling the mold with concrete, reinforced steel is installed. Workers don't need to measure where the rebar goes because all they do is place it in each of the horizontal and vertical cavities, which are called ribs. Hole formers are an important part of the Waffle-Crete system. They are plastic rods that form bolt holes in the concrete so that the panels can be bolted together when they are erected. Lifting hardware, called swift lifts, will provide a way to lift the panel into place when it's erected. Door and window openings can be easily added to wall panels by attaching wooden or steel blockouts to the mold. And finally, a layer of wire mesh is laid over the top of the mold. The mesh will reinforce the thin layer of concrete at the surface of the panel. This will prevent the concrete from cracking when it is removed from the mold, and will also provide shear strength to the panel when it is in place in the house. The panels are now ready for concrete. Panels are cast in 4 steps. The first step is to spread the concrete across the entire mold. The next step is to consolidate the concrete into the mold by using the Waffle-Crete vibrating screed. An aluminum screed is pulled across the surface of the mold to remove excess concrete and to begin smoothing the surface. Unlike many other building systems, with the Waffle-Crete system, the erection site can be prepared while the wall and floor panels are being cast. Site preparation will be fast and easy for our model house since we are building the house on grade on Waffle-Crete beams. Now back to our casting shop where the concrete panels are being floated to give them a smooth surface. A float finish is the simplest type of surface finish, but there are many different surface textures that could be added at this stage to change the look of the building. Once casting is complete, a special Waffle-Crete curing cover is placed on top of the mold. The temperature inside the mold will climb to almost 75 degrees Celsius overnight. In many cases, casting beds are set up outside right on the job site. In this case, the curing covers also protect the panels from the elements as they cure. The curing covers are removed first thing the next morning. The way concrete panels are removed from the molds is another Waffle-Crete innovation. Before the panel can be removed from the mold, the plastic bolt hole formers are popped out. Wooden wedges hammered into each corner help to separate the aluminum rails from the sides of the concrete. The many ridges and valleys of the mold tend to hug tightly to the concrete surface and therefore need a little help to separate one from the other. Once the panel is free, the mold can be cleaned in preparation for casting a new panel. Each Waffle-Crete mold can be used an average of 500 times before they need to be rebuilt or replaced. Unskilled workers can be trained to perform all the casting and demolding tasks you have seen in just a few hours. Because the insulated Waffle-Crete system accelerates the curing of the concrete, panels are strong enough to erect as soon as they come out of the molds. The Waffle-Crete grade beams will serve as a foundation for our model home, and so the 3 floor panels will be laid on top of them. When the floor panels are laid, they are interlocked with the grade beams like Lego pieces. The floor panels will be secured to the grade beams when the walls are erected. Once the back wall is lowered into position, it's braced to hold it in place. The walls will later be anchored through the floor to the grade beams with long expansion bolts. The waffle pattern you see in each panel is where Waffle-Crete gets its name. Waffle-Crete panels essentially work like a column and beam system. Each reinforced vertical rib acts like a column, and each reinforced horizontal rib acts like a beam. The concrete and steel in the areas between the columns and beams does not add to the panel strength, and so they are eliminated to significantly reduce material cost and panel weight without reducing the strength of the building. Another benefit of the waffle pattern is that a rim is left around the perimeter of the panel. Bolt holes are cast into this rim so that panels can be bolted together as they are erected. Normally, precast panels would need to have steel plates embedded into each panel, which are then welded to hold the panels together. Bolting panels together is something that the unskilled workers can do. It also makes the erection process go much more quickly. An independent analysis of the Waffle-Crete system by Stephen Andrews, a certified structural engineer, states that Waffle-Crete panels retain the design strength of traditional precast panels, yet are 60% lighter than standard panels of the same thickness. On a typical project, a crew of 4 workers can erect up to 25 panels in a day. The result is a solid structure that uses up to 60% less materials, can be built with unskilled workers, and is completed at lightning speed.